Today, we're diving into the story of Vanuatu, an island nation that is, in no uncertain terms, on the front lines of climate change. We're going to look at some incredible science that's not just about tracking the danger of coastal flooding, but about actually visualizing and building a much safer future.
And when we say front lines, this is what we mean. This isn't a simulation. You're looking at the raw power of the ocean just eating away at the land. For the people who live here, this isn't some abstract problem for a future generation. It's happening right now. Their homes, their roads, their entire way of life is at risk today.
So here's our game plan. First, we'll get a handle on the specific threat Vanuatu is up against. Then we're going to geek out a little on the science of what actually causes a massive coastal flood. After that, we'll see why measuring this stuff is so tricky. And finally, we'll get to the really cool part, the amazing technology they're using to map out a more resilient path forward.
Okay, so let's dig into why Vanuatu is in such a uniquely vulnerable spot when it comes to the rising ocean. You know, it's easy to think of sea level rise like filling up a bathtub. The water just goes up evenly everywhere. But that's not how it works at all. This map shows the reality. See all that red? That's a hot spot. The Western Pacific, where Vanuatu is located, is seeing the ocean rise way faster than the global average. They are, quite literally, in the crosshairs. And that faster rate, it adds up. Just between 1993 and 2020, the sea level around Vanuatu shot up by an average of 10 to 15 centimeters. Now, that might not sound like a lot, but imagine your front step being permanently a half-foot closer to the water. It fundamentally changes the baseline that coastal communities deal with every single day.
Okay, so you've got this higher baseline sea level. But a really devastating flood, what scientists call coastal inundation, is way more complicated than that. You can think of it like the recipe for a perfect storm, where a bunch of different ingredients have to come together all at once. And this diagram just lays it all out perfectly. The total water level during a flood isn't one thing. It's a whole stack of things. At the very bottom, you've got your mean sea level. Then, layered on top of that, you have the regular daily tides. A storm can add a huge bulge of water called a storm surge. And then, on top of all of that, you have the raw energy from wind and waves. When all of those things peak at the same time, well, that's when you get a massive inundation event.
So the key takeaway here is that it's this dangerous combination that creates the perfect coastal storm. You've got the long-term creep of sea level rise, the predictable daily rhythm of the tides, the sudden punch of a storm surge, the power of crashing waves, and then you can even have these big climate patterns like El Niño that can warm up the Pacific and temporarily raise sea levels even higher. It's a whole lot to deal with.
Now, understanding all those ingredients is one thing, but trying to actually measure and predict when they'll combine, that's a whole different ballgame. And it turns out the tools we've been using for decades have a massive, and I mean massive, blind spot.
And this is the million-dollar question that scientists had to grapple with. For ages, we've relied on tide gauges to tell us what the sea level is doing. But think about it. Where do you put a sensitive piece of equipment? You put it somewhere safe, right? So these gauges are almost always tucked away inside sheltered harbors. So, what happens during a huge storm that's hammering the exposed parts of the coast?
And boom! This is the problem in a nutshell. On the left, that's the data from the tide gauge tucked away in Port Vilas Harbor during a monster storm, Tropical Cyclone Pam. It barely registered a blip. Looks like a pretty minor event. But on the right, that's the wave data from the exposed coast just a few kilometers away. It was a catastrophic, completely off-the-charts event. The tide gauge, our trusted tool, totally missed the real danger.
This line from the scientific report really says it all. Relying only on those tide gauges is like trying to understand a hurricane by looking at a puddle in your backyard. It's just not giving you the whole picture. And for a place like Vanuatu, that gap in information could be disastrous. It was clear they needed a whole new approach.
So, how do you fix a problem like that? How do you see what the gauges can't? Well, this is where it gets really exciting. A project called VanKIRAP developed a pretty revolutionary scientific model to do just that. What you're looking at here is a little piece of that solution. Scientists basically built a digital twin of Vanuatu's entire coastline. This super detailed, high-resolution computer model maps out every inch of the seafloor, every reef, every bay. This incredible mesh lets them simulate exactly how the ocean is going to behave around every single island with mind-boggling precision. So, how does this digital twin actually work? Well, first, they build that ridiculously accurate 3D map. Then, and this is the cool part,
They unleash chaos. They run thousands of computer-generated or synthetic tropical cyclones through the model to see what kind of damage they do. Then they layer on top of that the projected sea level rise for the coming decades. What do you get at the end? You get incredibly precise calculations of extreme water levels for more than 2,000 different spots along the coast.
And this is the result. This isn't just a guess, it's hardcore data. This table shows the model's predictions for a 1 in 100-year flood. Just look at the town of Anagohan down at the bottom. Today, a storm like that might bring a flood of 1.38 meters. But by 2090, if emissions are high, that same kind of storm could bring a flood of over 2 meters. Let that sink in for a second. 2.12 meters. That's almost 7 feet of water. Can you imagine that level of flooding sweeping through a low-lying coastal town? This is the power of the model. It takes a vague threat and turns it into a concrete, terrifyingly specific number that people can actually plan for.
And here is the real payoff. All of this unbelievably complex science doesn't just end up in a dusty report on a shelf. It's been transformed into this, the Vanuatu Climate Futures portal. It's an online, interactive map. Now city planners, engineers, and community leaders can go online, pick a scenario, and see for themselves which hospitals are in the flood zone, which roads will be cut off, which neighborhoods are most at risk. It literally turns data into life-saving decisions.
And that's really the big idea we're left with. What's happened in Vanuatu shows us it's possible to stop just reacting to climate disasters and to start proactively visualizing and planning for them. So it really makes you wonder, for all of us, now that we have this incredible power to see future risks so clearly, how are we going to use it to build a safer, more resilient world?